Hello and welcome. We are looking at the idea of impact forces and how impact forces can be reduced in certain examples of collisions. We are going to focus our work on cars and how they are designed to reduce impact forces, but it can be applied to other situations as well. Now imagine here we've got a car that's being tested by a vehicle company, so it's driven by a remote control with maybe a crash test dummy inside, but it's driven into a wall, and when it drives into the wall you can imagine something like this happens. So the car has smashed into the wall and it's got a rather damaged front end, but the idea of the way that front end is damaged is to reduce the impact force as much as possible. And the key idea here is that the longer the impact time, the more the impact force is reduced. So this car here actually has what's called a crumple zone, and that's the area for this example here. That's the area at the front of the car that's designed to collapse or crumple in a certain way, and it's designed to maximize the amount of time it takes for it to collapse. So that means the longer the impact time, the more the impact force is reduced. Now it might not seem like a great amount of time that this is increased by, but you can imagine if it took 0.1 second for this car to stop, if that was doubled to 0.2 seconds by adding a crumple zone, you can see you've doubled the amount of time it's taken for it to stop, and you can see then that that would increase the force greatly. It would actually could potentially half that force with which that car hits the wall. Okay, now that's not the only safety feature that we have in cars. Another set of safety features are more of the features that are inside the car. And if we take this idea of the longer the impact time, the more the impact force is reduced, we have various things inside the car. The first one is this idea of a safety belt. And you can imagine that if you were driving at about 30 miles an hour, or this car was driving at 30 miles per hour, this test car hits a wall, this dummy is going to hit this steering wheel at 30 miles per hour. But the fact that we've got a safety belt here, that means to travel from the distance here into the steering wheel is going to be reduced, because the safety belt is designed to increase the amount of time it takes to go from here to here. That's one safety feature. The second safety feature is the idea of airbags, and airbags are designed to do the same thing. When this car hits a wall, the airbag will deploy, and an airbag is obviously just that. It's a bag that very quickly fills with air, and that means for this dummy the time taken to go from when the face hits the airbag to when it hits the steering wheel, that time is increased, so it reduces the force with which that would hit the steering wheel. And the last feature that we have that we're going to look at quickly is this idea of these side impact bars, and similarly to the other two safety features, this is designed to increase the amount of time for a collision or for an impact, and that means that the force of the impact is reduced. So that's a couple of safety features that we have in cars that is designed to increase the impact time and therefore reduce impact force. I've got this idea of I've written change in momentum over here, because what basically happens is there is a change in momentum between when the car is moving and when the car stops, and to increase the amount of time for that change of momentum to happen, again, it's just based around this idea in this sentence that I've written here. So you should be able to evaluate these three ideas, and if you're given some data about how impact forces can be reduced, it's going to be about increasing that impact time and therefore to reduce the impact force. Anyway, that's just about me done for this video. Thanks for watching, and I'll see you again soon.